BASF inoculants offer soybean producers the opportunity to realize bigger yields and greater returns from their soybean seed investment. In fact, independent field trials have shown an average yield improvement over multiple locations and growing conditions of more than 135 kilograms per hectare versus non-inoculated seed. Millions of living organisms live in every cubic centimeter of soil found in a typical farm field. Some of these organisms, if not controlled, can cause disease. Others help break down decaying plant material, releasing nutrients back into the soil for future crops to use. Still others have developed mutually beneficial relationships with the crops grown in the field. Such is the case with the soybean plant and the bacteria Bradyrhizobium japonicum. We'll just call them rhizobia. After planting, as the soybean seed begins to sprout, it releases certain chemical compounds. If rhizobia are near the seed, either because they were already in the soil or because the rhizobia inoculant had been applied to the seed, the rhizobia are alerted by those chemical compounds that a soybean seed is nearby. In response, the rhizobia excrete their own chemical messages. These messages are picked up by specific receptors on the growing root shoots of the soybean plant. Very quickly, plant root hairs near the rhizobia begin to flatten and curl. A pocket is formed by the root hair, and when rhizobia are captured in this pocket, the process of nodulation begins. While this process is extremely complex, we know that the rhizobia actually penetrates the root hair membrane. An invasion thread is formed that grows down through the root hair and eventually enters the plant root cortex, the tissue layer found immediately below the epidermis, which is the outer layer of the root surface. As the invasion thread grows near, cortex cells are stimulated to rapidly divide, and it is in this area where the invasion thread ultimately enters a single cell. The rhizobia moves into the co-opted cell, and a symbiotic, mutually beneficial relationship is established. A distinctive nodule begins to form as these cells divide. The rhizobia receive nutrition from the plant. In turn, they produce nitrogen in a form used by the soybean plant for growth and grain production. BASF. We create chemistry.